With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello. So question is saying this: which of the following compound have sp3d2 hybridization? Right. So we have to find out that in which of the following compound which have the sp3d2 hybridization. Right. So let us try to solve this question. Actually, hybridization is a theoretical concept. Right. So to find the hybridization of particular compound, we have to use the concept of steric number. Right. So you can see here, if steric number, right, so if steric number, right, let's say I'm writing here, this is steric number, right, and this is our hybridization, right, so this is our hybridization, right, so if steric number comes out to be 2, right, so then hybridization will be sp, right, so then hybridization will be sp, right, and if steric number comes out to be 3, then hybridization will be sp2, right, and if steric number comes out to be 4, then hybridization will be sp3, right, and if steric number comes out to be 5, then hybridization will be sp3d, right, and steric number comes out to be 6, then hybridization will be sp3d2, right, so then hybridization will be sp3d2, right, so this is the basic concept, right. So now question arises how to find out the steric number, right. So to find out the steric number, you have to just do nothing, you have to just add the lone pair and bond pair, right. So for calculating the steric number, right, so you can see here, for calculating the steric number, you have to add number of lone pair, right, so 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 number of lone pair in particular compound plus number of bond pair, right, so number of bond pair, right, number of bond pair, right, so this is the basic concept, right. Now in this particular bond pair, right, so you have to just only consider the sigma bond, right, so you don't consider only pi bond, right, so you have to just consider sigma bond, right, so I can write here that is only consider sigma bond, right, so only consider sigma bond, right. So and just using this you can find out the steric number, and just if you find the steric number you can easily calculate the hybridization, right. So now if we see the first compound, that you can say BRF2 negative species, right. So if we talk about BRF2 negative, right, so let's start here, right. So you can see here, if you talk about first one, right, so that is BRF2 negative, right, so that is BRF2 negative, right, so this is BRF2 negative, right. So now you can see that bromine belongs to group 17, that means halogen family, right, and we know that in the halogen family there is a valence electron is 7, right, so valence electron is 7, right, so let me write here 1, 2, 3, 4, 5, 6, 7, right, these are the 7 valence electron, right, and there is a charge over here, right, so that means one extra electron is added to this compound, right, so that means one extra electron we have added, right, and we know that halogens are bonded by single bond, right, so halogens are bonded by single bond, that means one fluorine, there are 2 fluorine, right, so that means one fluorine attached with this and one fluorine attached with this, right. So now you can see there are 2 bond pair, and the rest of this becomes the lone pair, right, so that you can see this is one lone pair, this is one lone pair, and this is one lone pair, right. So now you can see here in this particular species there are 3 bond pair, not 3 bond pair, 3 lone pair, right, so 3 lone pair, right, so 3 lone pair plus these 2 sigma bond, right, so these are 2 bond pair, right, so these are 2 bond pair, right. So now total becomes 5, right, that means our steric number becomes 5, right, and you can see here that if steric number is 5, then what is the hybridization? That hybridization is sp3d, right. So for this particular species the hybridization becomes sp3d, right. So you can easily find out rest of this, right. So let's try to for another, that is another species, that is ICl4 negative, right. So if I talk about the ICl4 negative, right, so you can see that is ICl4 negative, right. So actually these are the intrahalogen compound, right. So because both the atoms are halogens, right. So now you can see here iodine is also a halogen, right. So and valence electron is 1, 2, 3, 4, 5, 6 and 7 valence electron, and this is one negative charge over here, so you can just add one electron over here, right. And now you can see here there are 4 chlorine attached to it, right. So 4 chlorine attached to it, you have to just add 4 chlorine, right. So 1, 2, 3 and 4, right. So that means these 4 chlorine attached, right. So now you are left with 2 lone pair, right. So this lone pair and this lone pair, right. So now you are left with 2 lone pair, right. So you can write here 2 lone pair plus and 4 bond pair, right. So 2 lone pair and 4 bond pair, that makes it 6 steric number, right. So which corresponds to sp3d2 hybridization, right, which corresponds to sp3d2 hybridization, right. And if you talk about the C, right, so C species, that is ICl2 negative, right. So if you talk about the ICl2 negative, right, so you can see here ICl2 negative, right? So the ICl2 negative species, you can see here, that is ICl2 negative, same species, right, as like ICl4, right? Here the iodine is also our central atom, right? So the valence electron is 1, 2, 3, 4, 5, 6 and 7, right? And one electron, then one negative charge over here, that means one extra electron is added, right? So now you can see here, chlorine, there are two chlorine, right? So you have to make this two chlorine, one chlorine here and one chlorine here, right? So the rest of it becomes lone pair, right? So this is one lone pair, this is one lone pair, and this is again one lone pair, right? So now you are left with three lone pair, right? So three lone pair, right? So this is three lone pair plus two bond pair, right? So three lone pair plus two bond pair, right? So this becomes the steric number equals to 5, right? So this becomes the steric number equals to 5, right? So which corresponds to the sp3d hybridization, right? So the sp3d hybridization, right? So if I talk about the D, right? So D, the complex D, right? So now you can see here in the D complex, or not D complex, there's actually is a compound, intrahalogen compound, right? So IF7, right? So you can see here this is IF7, right? So now in this particular compound, iodine is our central atom, right? So 1, 2, 3, 4, 5, 6, 7, right? So because there is no charge over it, this is neutral compound, right? So that means 7 electrons are there, right? So valence electron, right? So just you have to add 7 fluorine, right? So that means 1 fluorine here, 1 fluorine here, right? So and 1 fluorine 3, that is 4th fluorine, and that becomes 6th fluorine, and it becomes, that is 1, 2, 3, 4, 5, 6, and this becomes the 7th fluorine, right? So now you can see here in this particular compound, right? So they are 0 lone pair, right? So that means 0 lone pair, right? And 7 bond pair, right? So in this way you can see this, the hybridization becomes the streak number comes out to be 7, right? So now you can say, you can write one more, that is, if the streak number comes out to be 7, right? So if streak number comes out to be 7, then hybridization becomes sp3d3, right? So hybridization becomes sp3d3, right? So you can write down, right? So this is the, in this case the hybridization becomes sp3d3, right? So the hybridization becomes sp3d3, right? So now, but in the question we have asked that in which of the following space that which have a sp3d2 hybridization, right? So you can see here in Brf2 negative sp3d hybridization, right? While in the case of ICl4 negative, right? So while in the case of ICl4 negative, the hybridization is sp3d2, right? So this is the sp3d2 hybridization, right? And while in the case of ICl2 negative, that is sp3d, right? And in the case of IF7, the hybridization is sp3d3, right? So this will be the correct answer, right? So this will be the correct answer, right? So let's try to choose the option. So you can see here the correct answer will be, you can see here the correct answer will be ICl4 negative, right? ICl4 negative will be the correct answer, right? And rest of the option becomes wrong, right? So this A, C and D becomes the wrong, right? So hope this answered your question. So thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.